Hello everyone, welcome to today's digital classrooms on GCxGC-TOF in focus, enhancing non-targeted screening in challenging matrices. I'm Chung Kyung and I'll be your host for today. Shimadzu Asia Pacific is proud to announce an exciting collaboration with SepSolve Analytical to bring the GCxGC-TOF technology to you. This strategic partnership combines Shimadzu Asia Pacific's industry-leading expertise with SepSolve Analytical's specializations in multi-dimensional chromatography technology, creating a powerful platform for complex non-targeted analysis in modern laboratories. In this digital classroom, we are thrilled to have you join us today for what promises to be an insightful session on the advancement in gas chromatography and time-of-flight mass spectrometry. To make this session a smooth experience for everyone, please allow me to run through some housekeeping tips and console features which you can interact with throughout the session. First, we have the Share Experience icon. You can click on the various social media icons below the media player to share these digital classrooms with your friends, followers, and connections on various social network pages. We also have some resources related to these digital classrooms available for free download. You can identify this resource icon at the bottom of your console panel. Just click on it and you can download the files. Lastly, I would like to point out that the Q&A widget allows you to pose your questions. Just feel free to type your questions into the chat box anytime during the digital classrooms and click on the Submit button. Our speakers will try to answer as many questions as possible towards the end of the digital classrooms. Before we begin, I would like to take a moment to introduce our distinguished speakers who will guide us through today's topic. Our first speaker is Dr. Laura McGregor. Laura completed her PhD in environmental forensics at the University of Strathclyde in 2012, where her groundbreaking research focused on the chemical fingerprinting of coal tar contamination using GCxGC-TOF MS. Currently, she leads marketing activities at SepSolve Analytical, specializing in the applications of GCxGC and chemometrics to tackle complex sample challenges. The title of the talk today is Beyond GCMS, How GCxGC-TOF MS Enhances non-target screening in challenging matrices. Laura, we are eager to hear your insights. So the floor is yours, please.
Thank you very much for the introduction. Hi everyone, thanks for attending today. My name's Laura McGregor and I'm the Product Marketing Manager at SepSolve Analytical. And today I'm going to be showing how GCxGC-TOF MS can enhance compound separation, the identification and data analysis to overcome the limitations of one-dimensional GCMS for complex sample analysis. For those of you who aren't familiar with SepSolve, we're an instrument and solutions provider with headquarters in the UK, as well as technical centres in various cities across the world. And we've been involved with GCxGC for a long time, dating back to when the first generation of our benchtop mass spectrometers were introduced, way back in 2008. And we've been dedicated to the continued development of the technology for both hardware and software, to make it simpler to use, as amenable to as many applications as possible, and to have the flexibility to be used with the GC of your choice. So today we're going to be showing what we can offer in combination with Shimadzu's Nexus GC and autosampler technology. But why do we need GCxGC? Well, the more sensitive our detectors become, and the better we get at introducing a sample onto the GC, the more complex the chromatograms get. We may end up with many co-elutions, and it makes the data more difficult to interpret. So while this chromatogram may look pretty simple at first glance, the deeper we delve into it, the more we can see. And unfortunately, tools like deconvolution, like you can see here, aren't magic. The more co-elutions you have, the more difficult it will be to pull apart the co-eluting peaks, and the more difficult identification will become. So we need a way to overcome this and to ensure that we don't overlook any compound of importance, and that we can get confident identification of as much as possible within the sample. And that's where GCGC comes in, because here we apply a second separation on a column with a different stationary phase, so that we can separate the sample based on two different chemical properties and pull apart compounds that would have co-eluted in 1D GC. For example, it might be based on volatility and then polarity, or vice versa, depending on your choice of columns. But the key aspect is that it's giving improved separation, so you can gain greater insight into your sample composition. Now, I don't have a lot of time to go into too much detail about how GCGC works within this presentation, but what I will say is that the most essential part of the system is the modulator. You can't perform GCGC without it, and its job is to preserve the separation from the first column. So what it does is to periodically trap a portion of the analytes as they elute from the primary column, and then re-inject them as a narrow band onto the secondary column for further separation. So you can see that this process happens alternately throughout the run, and a side benefit is shown in the schematic here, where we get narrower peaks, which often boosts the signal to noise for better detection limits too. And then it's the job of GCGC software to take the modulated slices and stack them side by side so that they form the three-dimensional peaks in the surface plot that you can see here. Or alternatively, they can be viewed from above in the form of the colour plot, where the colour scale represents the intensity of the peaks. So in order to perform GCGC on an existing system, the key requirements are a modulator, which we'll cover in more detail shortly, and the appropriate software. And for the software, we can provide the ChromeSpace platform that allows both instrument control and data analysis to simplify everyday use of GCGC. It includes full qualitative and quantitative data processing, including deconvolution, fast group type analysis, and the option to add alignment and chemometrics modules as well. So basically everything that you need for GCGC data analysis. Now, before we move on to the modulators and see some example applications with GCGC, I just want to note that the modulated peaks can be incredibly narrow. They're often less than 200 milliseconds wide, so it means that you need a fast acquiring detector for GCGC. It's often thought that you need around 10 to 20 data points to accurately define a peak. Otherwise, the chromatographic resolution starts to suffer, as you can see here when we reduce the acquisition speed. And some quadrupole mass spectrometers, like the QP2020NX from Shimadzu, can scan fast enough to be acceptable for GCGC. But typically, when using quadrupole MS, the mass range is often reduced. So it does mean that it may have limited applicability for samples where there's larger compounds present, like in petrochemical analysis. And that's why we generally opt for time-of-flight mass spectrometry with the benchtop 2, as it can easily acquire data with speeds of 100, 200 Hz that's going to provide optimal results for GCGC. But it isn't just speed that's important. There are a number of additional benefits that the benchtop 2 can bring to non-target screening with GCGC. TOF instruments like benchtop 2 simultaneously analyse all ions, so that means that they're ideal for confident identification of trace level targets and non-targets in a single run. It also delivers full range spectra with powerful mass accuracy within 50 ppm and direct matching to existing libraries to help boost confidence in every identification. And finally, its unique tandem ionization capability adds another level of detail with complementary soft EI spectra, which we'll see an example of shortly. And for 2025, we've made a few updates to the benchtop 2 design to further enhance performance. The updated system features a redesigned ion source that enhances the robustness and simplifies maintenance. These improvements can reduce the reactivity, prolong cleanliness of the source, and minimise downtime, while the user-friendly alignment means that it's easier than ever to maintain the instrument. And additionally, a new straight-through transfer line design also simplifies column fitting, it eliminates cold spots and leaks, and reduces the risk of damage during routine maintenance, ensuring greater stability and performance. So by enhancing these core strengths and introducing thoughtful improvements, the BenchTOF 2 ensures that labs can maintain peak productivity while achieving unparalleled analytical accuracy. But what is the added value of non-target screening by GCGC with TOF MS? Well, if we take this cigarette smoke, for example, it's a very complex sample that clearly has benefited from the additional separation of GCGC. But when we zoom in on a small portion, we can see the wealth of information that we're getting on the sample. And because you've physically separated the peaks, then you get cleaner spectra when you've connected with a mass spec in order to identify all of the peaks. So you don't have to only rely on deconvolution like in the earlier 1D example that I showed. But for some samples, challenges can still remain. For example, if we're trying to identify the circled peak here, we can see that the two top library hits are both pretty good matches. How can we be sure that we're identifying the correct compound? You can, of course, look into using retention indices as a way of confirmation, but with the BenchTOF 2, you can also rely on the mass accuracy to help add confidence. Because with the BenchTOF 2, we know that the mass accuracy will be within 50 ppm, so it can help us eliminate possibilities and confirm the correct identity. In this case, using the built-in master formula calculator in ChromeSpace software, we confirm that the top hit is indeed correct, as it falls within the 50 ppm specification of the instrument, whereas the second hit is well outside of that window. Now at SepSolve, we can provide GCGC configurations to suit every application, like you can see here for both flow and thermal modulation installed in the Shimadzu Nexus GC. Flow modulation is ideal for labs requiring routine high-throughput analysis or discovery-based applications involving volatiles less than, say, C7, such as aroma profiling. While thermal modulation is ideal for labs requiring the enhanced sensitivity and peak capacity that's needed to characterise trace-level compounds in very complex matrices like petrochemical fingerprinting and environmental forensics. Now for the remainder of this presentation, I'd just like to take a closer look at the two different types of modulation that we can offer and show example applications for each using the GCxGC-TOF. Starting with flow modulation. The key advantages here are, unlike in thermal modulators, there's no reliance on a cold jet to trap analytes, so they're consumable free, simply using differential pressures to fill and flush a sample loop. It also means that there's no volatility restriction. Volatiles from C1 upwards can be modulated, and that expands out the application range for GCGC. And additionally, the consumable-free nature plus the simple valve-based design means that both the capital and running costs can be kept low, so it's often considered a good stepping stone onto GCGC. And finally, the precise control of flow in both columns also results in excellent repeatability, making it amenable to routine analysis and large sample batches. So how does it work? Well, the Insight flow uses a 5-port design. You can see in this animation the 2 ports at the top are actually welded onto the back of the plate, which is why you can't see them in the photo of the modulator itself. When it's running, the analytes have been separated on the first column, and enter the modulator at the central port and begin to fill the sample loop, which you can see in the photo here. The valve outside of the oven then switches position to redirect flow to flush the sample loop contents onto the second column. And that process just happens alternately throughout the run. We fill in one direction and flush in the reverse direction onto the second column where the analytes undergo further separation. So that's why it's known as reverse fill flush flow modulation, because we fill in one direction and flush in the reverse direction. So that happens alternately throughout the run to provide modulation of all components in the sample. And it's important to note that the flushing step happens very fast, using high flow rates through the second column, and that's how we compress the chromatography. And the reverse fill flush method means that there's no way for the analytes to break through on to the second column. If we overfill this sample loop, the analytes would be directed to the bleed line. And this can be connected to an FID to ensure that there has been complete transfer of analytes. But in reality, the flow calculator that we provide ensures that you won't overfill the loop. Now, I should also mention that this loop volume can be changed, so we can provide different loop volumes to be fitted to the modulator to allow greater flexibility in the method development. And of course, we are simply filling and flushing the loop, so that's why there's no volatility restrictions. The very volatile species can be modulated as efficiently as semi-volatiles, so it makes it a good fit for discovery approaches and applications like aroma profiling, where there might be many volatile species present. For example, here we have an aroma profile from a plant-based meat that was captured using GCxGC-TOF with the insight flow. And we can already see the additional detail that has been captured by GCxGC. But if we zoom in on a section that you can see on the right-hand side, we can see that how it really helps in aroma profiling, because there's a number of high-loading analytes that are aroma active compounds, but if this had been run in 1D-GC, they would have masked out all of these other smaller peaks that you can see in the colour plot below. And importantly, many of these are also aroma active, like the pyrazine that gives a nutty aroma, and the thiophene that gives an oniony aroma. So it's important to be able to capture all of this information, as it will impact the overall perceived aroma of the food or drink sample. And it's details that would have been missed in 1D-GC-MS. Now, because of all that extra information that you get when using GCxGC-TOF, the data processing has often been compared to looking for a needle in a haystack. But thankfully, this is no longer the case. There have been many software advancements in recent years. At SepSolve, we use our own Chrome Compare Plus software to automatically process the GCxGC datasets and quickly identify the key differences between complex chromatograms. Like you can see in this case, where we've quickly found a sulfur compound that was increased in some of the plant-based meat compared to the low levels that were found in ground beef. So we can quickly find compounds like this that will have an impact on the perceived aroma, and that's really helpful in flavour development and understanding consumer preference. And in another example of aroma profiling, it may be the case that we want to very quickly find differences in quality. So here we have two examples of different curry powders that were analysed by GCxGC and the benchtop 2, an expensive one and a cheaper alternative. Now, they actually look quite similar at first glance, but there are major differences when it comes to the ingredients that were listed on their respective packaging, with more varied and better quality ingredients listed on the expensive powder. So how long would it take you to find and identify all of the differences in this data set? It would probably take quite a while. But with the Smart Subtract tool for Chrome Space, it took minutes to generate and report the peaks from 2 subtracted chromatograms. What this tool does is to use probability-based subtraction, so it's improving the results compared to the regular or conventional subtraction, to help quickly find key differences. So here we can see the first subtracted chromatogram, the expensive minus the inexpensive curry powder, where we're seeing markers of high quality from the more expensive ingredients like star anise, cardamom and cinnamon. While in the subtracted chromatogram for the inexpensive minus the expensive curry powder, you can see the compounds that are more indicative of low quality. So things like these thiocyanates that may be from the ingredients like mustard that weren't present in the expensive curry powder. And that's information that is equally important when it comes to developing new products. And with Smart Subtract, we're able to find these and report out the list of differences in minutes. So it really is simplifying the use of GCGC and making the most of that data. Now finally, in aroma profiling, there is one remaining challenge, and that's the identification of isomers, where the additional mass accuracy of the benchtop 2 won't help us because they do share the same molecular weight. And this is a good example of where the tandem ionization capability can be useful from the benchtop 2 because it gives complementary soft EI spectra to help us identify these compounds. For example, we have 2 diterpenes from a hop oil here that look very similar when we look at the 70 EV spectra with quite weak molecular ions at 272. But then when we look at the 12 EV, we see differences in the ion ratios that can help us to identify the individual isomers more easily. So it's adding another level of confidence to the identification. So moving on to thermal modulation now, this is a more sensitive approach because the analytes become enriched in the carrier gas, while in flow modulation they're effectively diluted in the high 2D flow rates that are used. The cold jet here is used to trap the analytes, and it also provides focusing to produce sharp, narrow peaks and a greater boost in sensitivity. And those sharp peaks also help to improve the peak capacity for even better separation of the most complex samples. And finally, it is thought of as being simpler in terms of method development, though recent improvements in flow modulation have gone a long way to improve the flexibility and the ease of use during method development, like the adjustable sample loop volumes, for example. So what can SepSolve offer for thermal modulation? Well, we have the Insight Thermal that you can see here. It's a cryogen-free thermal modulator that uses delay loop technology. Now that means that the column loops between a pair of jets that are held within the GC oven. Now, in this case, we've got the column holder here where the column loops between the cold jet and then the hot jet. And the jets are using cooled and heated gas, either air or nitrogen, to alternately trap, then release the analytes. And as I said, it's using cryogen-free technology, so it's a chiller unit that provides the cooling of the gas rather than liquid nitrogen. And if we just zoom in on this section and look at the underside of the column holder, we can see how it works in a little more detail. So here we can see the underside of the column holder, where the column is looped in this figure of 8 pattern between the jets twice. So in the modulation process, the cold jet is always on. So when the analytes enter the modulation loop, they get trapped by the cold jet. The hot jet then pulses on for a short time, and that deflects the cold jet and releases the analytes, where they make their way around the loop to the next cooling stage of the modulation process. So they're once again trapped by the cold jet, and then the hot jet releases them, where they make their way around onto the second column. So unlike flow modulation, where we use high flow rates in the second column to compress the chromatography, here the focusing is achieved via the jets, and the analytes become enriched in the carrier gas, so you boost the sensitivity. And that's always been one of the key advantages of thermal modulation. You get sharp, narrow peaks for greater sensitivity and greater peak capacity for better separation. And a limitation of legacy thermal modulators has been that it was quite a challenge to install the column set and ensure that the loops were well aligned between the jets and, importantly, stayed well aligned throughout the analysis. But here, the patent pending design of this column holder resolves the issue. It can be removed from the device to allow installation of the column outside of the GC oven, and this figure-of-8 design basically locks the loops in place as the column is wound around the holder. So it means that it can be installed quickly and easily, and if we zoom in on the front of the design, we can see that there's small grooves there that just help to keep the column in place to ensure that they are precisely aligned between the jets and stay aligned while the analysis is running. So once the column holder is slid into position, it's not going to move around during or between the runs. And one of the key advantages of the system is the integrated control within Chromespace software. So you're able to sequence sample analysis and leave it running, even if you want to run different sample types using different methods and modulation parameters. So it means you can get confident, unattended analysis and simpler, more flexible method development, and ultimately a benefit in productivity. And if we take a closer look at the methods themselves, and you can see in the method, we've got full control of all of the parameters that you would need for the modulator. You've got variable modulation times and unlockable parameters that can be moved to the sequence table for easy editing, as well as ramped rates for the hot jet temperature and then the cold jet flow rate. And that's extremely important in thermal modulation. So just to emphasise the importance of this, I've got a few examples here showing the difference between running with and without ramped cold jet flow rates. At the top, we can see a constant flow rate of about 4 litres per minute that was used. And in this case, it wasn't sufficient to trap the more volatile components, so we get streaking at the front of the chromatogram here. If we increase the cold jet flow rate to around 15 litres per minute and use constant flow, the volatile compounds are more efficiently trapped and you get better chromatography at the front end of the chromatogram. But what happens for the high boilers is that they're not efficiently launched by the hot jet. You get irreversible trapping of them because the high flow rate has made the trapping temperature too cold. And you get this tail happening across the chromatogram to the extent that you begin to lose those high boilers completely. Then finally, at the bottom, we have a ramped flow rate that was used, where we decreased the cold jet flow rate as the run progressed, and you can see that we've got good chromatography across that wide analyte range. So what it means is that the Insight Thermal has the ability to extend the analyte range for thermal modulated GCGC. It has that ability built into its design to provide linear ramps that are fully automated within Chromespace methods. And the results of this are obvious. We've got excellent chromatography here for GCGC-FID in this case, for a vacuum gas oil, with efficient modulation of C50+. But to see some more examples of GCGC-TOF, let's take a look at pyrolysis oils. Because there's been increased focus on sustainable fuels in recent years, such as those from pyrolysis of plastic waste. But the composition of these pyrolysis oils can vary depending on the type of plastic feedstock used and the pyrolysis parameters that were used. Now, typically, they contain a complex mixture of various hydrocarbons, like the ones that are shown here, but they can also contain trace impurities like sulfur, nitrogen, oxygen, or chlorine-containing compounds, and these all affect the quality of the oil and its applicability. And unfortunately, the unknown chemical composition and the extreme complexity of pyrolysis oils means that complete characterization is a challenge for 1D GCMS, particularly in terms of individual compound identification. But it is a job that's well suited for thermal modulation with the benchtop 2. And here we've got a 3D plot of a pyrolysis oil from mixed waste plastic, and it gives a good perspective of the varied intensity and range of analytes that are involved. And highlighted in the centre of the magnifying glass at the bottom of the image here, you can see a small peak that in a 1D separation, it would have co-eluted at exactly the same time as all of these other peaks above it in the surface plot. So it would have made it very unlikely to be detected and almost impossible to identify. Yet here we can see that it is confidently separated out from all of these other peaks, and it can be identified against a reference library to give the match that we can see on the right. And importantly, this is a chlorine compound that may impact the quality of the oil and its applicability. So it's vital to achieve this level of detail that GCxGC-TOF MS can provide. And in the search for these trace contaminants, software tools are equally important because in this case, we've got a pyrolysis oil from scrap tyres in the back plot. The TIC version is here. And then we've got two filtered chromatograms from Chrome-based software. These were generated using expressions to search for specific classes of compounds. So the nitrogen-containing quinolines in the middle, and then any sulfur-containing compounds at the bottom. So these filtering expressions can be specific to an individual compound or a class, or they can be broad to search for a distinctive isotope pattern, for example, chlorine, or for neutral loss, like here for the sulfur compounds. And a new filtered chromatogram is generated that contains only the peaks that have passed the expression. So it makes it easier than ever to identify and find your compounds of interest, even if they are at trace levels. And when it comes to thermal modulation, the boost in sensitivity and separation capacity is also ideal for applications like environmental investigations, where you're not only looking to identify the trace target contaminants, but you also want to screen the sample for other compounds of emerging concern. And this example here is actually an extract from passive sampling of river water over a period of 4 weeks. And clearly we've got a high level of complexity. The Insight Thermal in this case has given the ability to do screening of the full sample. And here I've just highlighted 4 examples of emerging contaminants and their suspected sources, such as tire pollution from road dust that runs off into the rivers, or compounds from cosmetics or personal care products. And as you can see, they're all very trace components, and they cover a wide range of chemical classes. But they've all been captured in this single run. And that's really the beauty of GCxGC-TOF, being able to capture all of that information for non-target screening in a single analysis. And finally, we also applied the thermally modulated system to screening of complex essential oils. And here we wanted to look at the differences in essential oils of different quality, and we benefited from the huge peak capacity and boost in sensitivity from the focusing of the Insight Thermal Cold Jet. And we've got narrow peak widths here, less than 100 milliseconds wide in a lot of cases. So that meant that the fast acquisition speeds of the benchtop 2 were an absolute must. And unlike in 1D, where the chromatogram would be dominated by these higher loading components that are quite highly coloured in red here, we can easily see trace differences in this case between the two chromatograms. And that's really important for the essential oils because the trace components can indicate issues in quality from different preparation methods or changes due to poor storage conditions. And if we zoom in on the highlighted region here, we can see that there are some of the pungent compounds from ginger, like the 6-paradol and 6-shogol, that are clearly present in higher amounts in the premium ginger oil compared to the cheaper ginger oil. And these would have co-eluted with a lot of other peaks in 1D separation and might have been more difficult to identify. But with GCGC and BenchTOF2, they're confidently characterised so that you get much greater detail on the sample composition. So in summary, GCxGC-TOF MS provides comprehensive sample characterisation for a wide range of sample types. The physical separation of peaks gives cleaner spectra for better identification. And with detectors like the BenchTOF2, you can compare the spectra directly with existing libraries and have the added confidence in identification that the powerful mass accuracy and tandem ionisation technology can bring. With both flow and thermal modulation configurations, then we're able to tailor GCxGC systems to suit your needs. And these come with the easy-to-use data processing of ChromeSpace software. And finally, with the software tools like Chrome Compare Plus and Smart Subtract, we're making it easier than ever to quickly generate simple, user-friendly results out of the complex GCxGC data. So that brings me to the end of my part of this presentation. Thank you very much for listening. If you do have any questions, please do type them into the question box and we'll try to answer as many of these as possible at the end. But for now, it's over to Dr. Jackie, who's going to tell us more about the performance, ease of use and versatility of the Nexus GC2030 in combination with GCxGC.
Thank you, Laura, for that compelling presentation. Your expertise in GC by GC applications truly highlights the potential of this technology in addressing complex analytical challenge. Next, we are pleased to welcome Dr. Jackie, who holds a PhD in analytical chemistry from the National University of Singapore. With over a decade of experience in research, training, and facilitation, Jackie has dedicated his career to connecting with scientists across various industries, sharing invaluable technical knowledge and helping them navigate their GC-related analytical needs. The title of his talk today is Unlocking TOF's Potential, the Ultimate GC Partner. Jackie, we look forward to your presentations.
Hello, everyone. Good day. And thank you, Chung Kiang, for your introduction. Everyone, my name is Jackie, and I'm going to present to you the ultimate GC partner to the TOF, which is our Nexus GC2030. Known as the living GC, Nexus GC2030 has multiple features that makes it the perfect partner for the TOF. And these three features I'll be explaining in these coming slides in the presentation. Firstly, the exemplary, robust, and efficient performance. This allows us to acquire just enough data with minimal reruns because the data that has been obtained are also reliable. A lot has to be credited to the intelligent flow controller that has been equipped by the Nexus GC2030. Our advanced flow controller has individual CPUs that allows for super precise flow control within each injector pod. So there is an integrated chip that allows us to improve the flow stability as well as providing feedback directly back to the injector when there is any changes in fluctuation or any of the control modes. This allows us to obtain exceptionally reliable results, such as the table that you will see on the right here. This is known as the group test mix, a mixture of various functional groups from alkane, alkene, alcohol to even esters. And you will see that the peak area value as well as retention time has exceptional RSD value, meaning the results are very, very precise. And this intelligent flow controller allows us to manage the system in various flow modes, such as constant linear velocity, constant pressure, and constant flow mode. Now, the constant linear velocity is a Shimadzu proprietary method that can be very effective in long run. When we are performing GC and GCMS analysis, typically the difference between them would be the pressure at the detector. Yes, the back pressure at the detector is different, such as in TOF, it is a vacuum, so it would have a much faster flow rate if it is not properly managed, compared to when the flow is flowing towards an FID, which operates at an atmospheric pressure. If we are able to manage this separation by constant linear velocity, we are able to maintain the optimum separation efficiency as dictated by the Van Dimter's plot. And as a result, we can perform optimum resolution. Whatever method that has been established, the separation is optimal, and there is a seamless transfer between GC and GCMS. So even when we are changing between different carrier gases such as helium, hydrogen, and nitrogen, you will not see any difference in the separation efficiency. And on the right side, this is an application where we are transferring method from GCFID to GCMS. So when we are using constant linear velocity mode, you can be assured that even when we are doing a splitter where we are having the TOF and FID analysis, there will be no change in the retention time at all. So this allows us to have easy identification as well as precise quantitation. The Nexus GC comes equipped with one of the best detectors in the world in terms of general detector, and that will be the FID, the flame ionization detector. It has the most sensitive minimal detectable quantity in the market, and it is able to acquire data at 1 millisecond. This is perfect for fast GC as well as GC by GC, which Laura has mentioned earlier, but I'll show you more detail in a while. In addition to that, FID needs to be run on hydrogen. And we have not just the hydrogen sensor in the GC, there is also other precautions in the FID, such as the automated flame cut-off when there is no gas supply, to ensure that there is no leak of hydrogen, whether it is in the GC or in the FID. Now, typically, the FID is used for various applications, such as the analysis of residual solvent in pharmaceutical, as you see on the left chromatogram over here, or the nicotine in e-cigarette liquids on the right chromatogram. But when combined with GC by GC, we can actually see the application on analysis of aviation turbine fuel, known as after, that is compliant to the analysis of ASTM D8396. So this allows us to have a group type analysis. And so we can see here, paraffins, naphthenes, aromatics, and so on, they can be separated in 2 dimensions and quantified using the FID. The ComSpace software that is provided with the TOF has a capability of stencil function, and this can be very helpful for us to do automated group type analysis, such as we can produce the simple the presentation of quantitation in a simple area percentage format. And if you are into productivity, because this can be a very routine analysis, what we can do is to connect 2 different sets of flow modulator in this single GC, and that allows us to use 2 injectors, 2 columns, 2 flow modulators, and of course 2 FIDs. So both of them will be able to generate the data at the same time. And this simultaneous analysis doubles the throughput with 2 sets of FID within the same GC. The Nexus GC also comes equipped with the best specialized detector, SCD, sulfur chemiluminescence detector, which is specializing in sulfur compounds down to ppb or even lower concentration levels. So Shimadzu's SCD is unique in the sense that it has a very long horizontal redox cell that allows all the chemicals, whether or not it contains the sulfur, to be fully reacted. And as a result, we do not see any matrix quenching that can be caused by a non-sulfur compound eluting in the SCD chromatogram. Sorry. Now, so if you are not so familiar with SCD or FPD, some detectors that are capable of doing sulfur analysis, typically what happens is that there are oversaturation of signals coming from non-sulfur compounds, and it will appear as a false positive in these detectors. That is known as matrix quenching. Now with a flow cell, the redox cell that is so long, everything will be combusted, and therefore there will be no quenching effect even from the non-sulfur compounds. At the same time, we have a super short inert transfer line within the SCD that allows equimolar ppb level detection or even lower. The software is also really intuitive for easy maintenance and operation. So some of the applications for SCD include the analysis of trace sulfur compounds in gasoline, as you see on this left side, which complies to the ASTM method D5623, or there are some unique applications such as the analysis of trace sulfur in beer. Typically, beer has that bitter taste, and that can be accounted for by the sulfur compounds. Now, when we combine the SCD with GC/GC, we can get a very good specific chromatogram, as you see. Only the sulfur compounds will be called out. And this can help us to do the analysis of identification in TOF. Now, typically, sulfur compounds are really sensitive. Humans are really sensitive to sulfur compounds, even at really low concentration levels. They may be lost in the vast array of humps in the TOF chromatogram. But having the SCD, it will allow us to look at specifically only the sulfur compounds. And this is another way where we can combine the TOF, GC/GC, as well as detector splitter to enhance our application by having more precise identification. And thus, we can do quantitation from that. The Nexus GC also comes with seamless data analysis and management, so it allows us to have easy data processing and reporting. Now, the software that is used in the Shimadzu instrument is connectable by networking to the Shimadzu Lab Solutions CS. Now, this is an optional client server that allows us to have compliance with the most strict regulation out there, FDA 21 CFR Part 11, which is commonly used in the pharmaceutical industries. But it is only to say that our client server is so reliable that it can also meet the toughest regulation out there. Importantly, when we are connecting it with the TOF, we can also have link support. So this will be the key to a paperless laboratory, because with the data that is generated these days, we want to make sure that we don't lose them. And therefore, we want to have full integration in terms of process, instruments, and software. This can be provided by Shimadzu, where we have sample management, instrument management, data management, all part of the seamless integration between our client server as well as the lab instrument management system links. And in addition, if you are someone who is caring about intelligent analytics for your laboratory, Shimadzu also has a unique software known as the Lab Solutions BIX, which is important for us to manage the instrument utilization, user efficiency, as well as audit review. So this is typically the interface of the Lab Solutions BIX. It has a dashboard that tells you not just about the GC/GC-TOF that you are installing in the lab, but also any other instruments that you may have, so that we can look at what are the most efficiently used instruments in the laboratory. So this can be very helpful in saving costs in the long run. Now, the third unique feature about our Nexus GC is that it has exceptional versatility and productivity. So it allows us to it allows us to manage the lab not just for the current time, but also for the future. Take, for example, when we have maintenance. Now, there is no instrument to do without any maintenance. We have to perform them. What if we make the routine maintenance so simple that even the users can be as professional as they've been using the GC for a long time? And that is what we've been achieving and trying to do for the past 65 years. When we are putting the glass insert, for example, all we need is to use this click tag, a one-touch injection to to open the injector port. There is never a case where it will not be too loose or it will not be too tight. Even when we are changing the gas flow line, for example, maintaining the cleanliness of the gas flow line, these filters can be easily replaced by hand. So all we need to do is just to rotate this thing and the split filter can be removed. It is very easy to see when is the time to replace the gas filter because the color will change when the sample is really dirty. So this allows maintenance to be done with ease and even the new users can do it with confidence. If you are working on GC by GC, you should also note that there is intelligent design for hassle-free GC by GC. Take, for example, in the flow modulator. This is the flow modulator device, which is a very simple piece of metal where we can just connect the capillary columns and also the deactivated tubes according to the diagram. And if there is a need, we can even combine it with a flow patch splitter that allows us to split between a TOF and a FID, for example, or TOF and SCD. But if you are interested in thermal modulation, it is good to also note that the intelligent design of this figure of 8 is now making thermal modulation so much more convenient because there is much less requirement for us to replace the columns. And so we can minimize the amount of maintenance needed when we are using the GC by GC, whether you're doing flow or thermal modulation. So of course, with advanced flow technology, we can freely create any configurations. For example, we talk about FID, SCD, but you may be interested to also do an olfactory analysis or VUV or any kind of other detectors. Shimadzu's Nexus GC allows us to control multiple lines with a single GC without any additional software. So whether we are performing backflush or splitter or even hard cut and detector switching, this can all be done within a single method. And so it reduces the hassle for us to change configuration. And of course, if you are interested to have a different type of sampling than just a liquid autosampler, we also have thermal desorber, headspace sampler, a multi-purpose autosampler that is capable of automated sample preparation, as well as pyrolyzer. So with the TOF and the Nexus GC plus the Insight flow and thermal modulator, we have the perfect solution for us to perform any form of research and also routine work. If you're interested to know more about our products, Shimadzu has a digital classroom, which is an online repository of different various webinars that has been conducted previously, all categorized by different industries. And some of the topics that may be interested to you, especially related to the GC, may be the following. So if you're interested to, you can always watch them online for free anytime you want. And so with that, I would like to thank you for your attention. I'll pass the time back to Chung Kiang. Thank you.
Thank you, Jackie, for that insightful discussion. Your practical approach to GC-related technologies provide a valuable perspective for all of us in this field. So now, as we transition into our Q&A session, I'm excited to introduce our third speaker, Anthony Buchanan. Anthony received his master's degree in analytical toxicology and joined SepSolve Analytical in 2018. He has since evolved from an applications engineer to service engineer and now serves as the portfolio product manager for GC and TOF MS technologies. Anthony, together with Laura and Jackie, will be here to address your questions in the Q&A session. Now, let us welcome back Laura and Jackie to answer some questions. So please switch on your camera, please. Hi, guys.
Hi.
So the first question that we have today is, let me push this. The question is, how does the sample subtraction work? Does it work with 1D data too? So I think perhaps Laura is good to answer this question.
Yeah, I'll take that one. So that was actually a preview of a new tool that we'll be releasing at the end of this month called Smart Subtract. And unlike the simple subtraction that you'll be familiar with that's been around for many years, that type of subtraction can result in subtracted chromatograms that are just as busy as the original. But what we've done with Smart Subtract is to use probability-based subtraction. So it's got some other statistics that are working behind the scenes to ensure that any small differences between the high intensity peaks aren't going to dominate the subtracted chromatogram. So instead, you'll get a much cleaner background and focus on the key differences. You've suppressed the small relative differences. So the workflow is kept very simple, just like normal subtraction, but the results are smarter. So you get these subtracted chromatograms that then can be integrated, library searched, so you can quickly identify all the differences. And finally, yes, it does work with the 1D data as well. It's available as a plugin tool for the ChromeSpace platform. So it works with all the various file formats that can be used within ChromeSpace, including single quad data.
Fantastic. Thank you, Laura. Let's have a look at the second question. For the purpose of reverse engineering of product formula, like cosmetic or home care products, is GC-TOF suitable or just normal GC MS is sufficient? Maybe Laura, would you be able to take this question?
Yeah, I'll take that one because it relates to the answer I just gave, actually. For the reverse engineering, you wouldn't really want to miss any important compounds, especially ones that might impact, say, the flavor or fragrance. So I would say that GCxGC with TOF is a really good fit here because you're going to be able to get maximum information on the composition and then clearly see what the differences are between two products, especially when you do combine with tools like Smart Subtract, because then you can visualize those differences really easily. And we have done some work on this kind of analysis already for things like brand versus imitation perfumes and looking at the flavor profile of real meat versus plant-based products. So we've got some experience in those applications.
Thank you, Laura. So the third question is, in the flow modulation and thermal modulation, up to what carbon number can it modulate? And what about column specification for both? And how about accuracy in both the modulation techniques? That's actually three questions within one question. Perhaps, Anthony, would you be able to answer this question, please?
Of course. So I'll address the first question. In terms of the carbon capture between the flow and thermal modulation, so with flow modulation, as Laura touched on, it's really just using the carrier gas that your GC will provide to allow the actual function and modulation to take place. Due to that, there's no real restriction on the carbon number with flow modulation. It's really impacted by the type of sample introduction technique and the column selection that you use. So we can effectively modulate from C1. You'll just need to select the correct columns all the way up to C50, C60 plus, again, depending on the column set you're using. With thermal modulation, as we touched on, as Laura said in the presentation, ours is a cryogen-free model that we are providing. So we can effectively modulate from C7 with our cold jet and go again all the way up to C50, C60 plus, depending on the column selection that you would like to see. In terms of the column specifications, depending on the application, they can vary quite significantly, but there are a few things you kind of want to tie in depending on the modulator you select. With flow modulation, generally you want more narrow internal diameter, so narrow IDs of your primary column. Because we're using those lower flows, we want to get close to the optimal linear velocity as possible. So we prefer to use narrower IDs in flow modulation for the primary column, and then more standard 0.25 millimeter IDs for the secondary column. Generally, the flow modulator is also using slightly shorter columns, generally a 20 meter for the primary and around a 2 to 5 meter for the secondary. For thermal modulation, it's much more similar to standard one-dimensional analysis, where our primary column is normally something like a 30 meter 0.25 column, so more generic compared to what most of our users here would be used to. And then the second dimension column is also then quite short, normally 1 to 2 meters. In terms of accuracy, for retention time stability, both I can say we have numerous slides and data on this. They are both very accurate with the design of what we call the column holder we saw during Laura's presentation, allowing the columns to be presented in a very accurate manner for thermal modulation. It allows for the focusing to be done, and we do not get retention time stability shifting because the columns are held perfectly in place between both cold jets. With the flow modulator, because of the design of what we call the SIL flow technology, which are the ferrules that actually fit into the modulator, it means that we get no leaks. It's a very robust design, meaning, again, we're not getting any shifting in retention times. For then sensitivity, accuracy in terms of response, again, we have numerous data sets in terms of specifications to show that with GC times GC, just like you'd be familiar with standard detectors and sample introduction, it gives very accurate results.
Thank you for the insightful answer, Anthony. So the next question is, can I buy the TOF tool, bench TOF tool, and add it to my current GC in the laboratory? I think, Jackie, could you take that question, please?
Yes, great. I'm very happy to see this question. That means we are likely going to see an order coming soon. So anyway, yes, the short answer is yes. We can add the TOF to a current Nexus GC in your lab. But of course, please contact our local salesperson for more thorough checks, because we also need to see the condition of the GC. Let's say it already has a lot of different items on it. Let's say it already has an MS, then it is not suitable, but it is possible when the Nexus GC, for example, is only having one line and so on. So yeah, please contact our local representative. Thank you. Back to you, Chun Kiang.
Thank you, Jackie. The next question is also for you, Jackie. So the statement is, I want to use the smaller GC from Shimadzu. So I think it refers to the Brevis GC.
Yes. I did mention the Nexus GC. We are still currently developing the combination of the TOF with our Brevis GC. So please look forward to it. For now, we can only use the Nexus GC for connection with the bench TOF tool. Back to you, Chun Kiang.
Thank you, Jackie. The next question that we have is there any application of GC by GC TOF for the analysis or detection of microplastic in any various matrices? Very hot topic now. Anthony, would you be able to take this question?
Of course, yes. As you said, microplastics is quite a hot topic at the moment in varying matrices, be it in air, in soil, or water is common, the ones we're kind of analyzing. Yes, we have done work with GCGC time of flight for these application sets. Often depending on what matrix you're selecting, the level of complexity of that matrix then may lean towards doing GC times GC, for instance. So we have looked at microplastics and things like soil or landfill gas, where it's a much more complex, rich matrices, where you've got numerous contaminants that might be present, where GC times GC really shows its own. Even in what you would expect to be kind of clean matrices like water, you can, depending on if it's water coming from something like effluent, from a stream or from a factory, you can still get quite high levels of contamination. So again, we have used GC times GC to assist with the separation of that and analyze the kind of detections you would need. Depending on the matrix, we would then select either the front end analyzer, and then sometimes you don't necessarily need GCGC if it's a more cleaner matrix and the time of flight may be sufficient. But any further questions, we'll be happy to share an application note to highlight microplastics after this presentation with that.
Thank you, Anthony. Again, very insightful. And the next question that we have is, how do we correlate the scanned seconds to the hertz? 400 hertz is how many scans per second? I think, Laura, would you be able to take this question?
Yeah, I'm happy to take that one. It's a very good question. It's something that highlights the difference between TOF and quadruple MS, because unlike quad systems, TOF isn't a scanning MS, so it is looking at all ions all of the time. So what the BenchTOF 2 is actually doing is acquiring 10,000 full mass range spectra per second. And then that's just the native rate that is applied. So that's then summed into what we call scan sets. So 10 hertz would actually be 10 scan sets per second, and each scan set contains 1,000 full mass range spectra within each. So it's a lot of detail that you're getting there.
Okay, thank you, Laura. Another hot topic that we have received is Moshmoa. Is it possible to just add a modulator to my GC for Moshmoa analysis? Do you have the columns and methods to recommend? Jackie, would you be able to take this question?
Yes, I'd love to. Another hot topic. So for Moshmoa, typically we will be using the LCGCFID for the application, but GC by GC is also another wonderful tool to perform this analysis. And so we can definitely add a thermal modulator to the GCFID for this analysis. And of course, TOF would be a perfect tool as well, you know, like when you want to segregate the MOA fraction, for specifically whether this is actually a MOA or maybe it comes from the PAH family or some other false positive result. TOF actually would make a very good tool too. So you can add a thermal modulator and a TOF to the GC to perform this analysis. As for the column and method, yes, we do have such recommendation. So please contact our local salespeople for more information. Thank you. Back to you, Chun Kiang.
Okay. Thank you, Jackie. So we are seeing some questions coming in still. So please feel free to send in more questions so that we can answer them today. So let's move on to the next question. The next question is, could GC by GC TOF assist in odor, taste evaluation of esters of the oleochemical industry? Anthony, would you be able to help with this question?
Of course. This is a good question, and it's often a key application area that we have actually done a lot of work in. In the food fragrance industry, we have done plenty of applications with GCGC and our time of flight instrument to look at things like odor and taste that do have a dramatic impact. in the presentation that Jackie touched on in terms of looking at beer analysis, he referenced those sulfurs that can have quite an impact on taste and odor during the actual analysis. Now, those sulfur compounds are often quite small in comparison to all the other matrix that might be present. So with the power of GCxGC, that allows us to then highlight and identify those smaller trace level components in an easier manner. We have analyzed numerous different types of sample matrices, be it plant-based meat, as Laura touched on. We work with plenty of universities that analyze things like plant material, biogenics, to look for those kind of small differences in the actual material itself. It's worth noting as well, we have paired our device with the olfactory or odor port. So if you were interested in actually seeing the odors that come off the analysis at the same time as running the GCxGC time-of-flight system, this is something that we can actually do as well.
Thank you, Anthony, for the answer. The next question is bench TOF okay to be used with, say, hydrogen or nitrogen carrier gas instead of helium? So thank you for all the questions. I'm afraid that we're running a bit short of time, so this may be the last question for the session. So for this question, may I invite Anthony again? Would you be able to take this question?
Of course. As we know, the selection of carrier gas with various detectors is becoming more and more important with the cost of helium going up and the shortages globally. So yes, I'm pleased to say that with our bench TOF, and worth noting both of our modulators, we can use both hydrogen and nitrogen as our carrier gas. As I'm sure most people are aware of this, with nitrogen, you may expect a slight drop in response just due to the nature of the carrier gas itself. But our time-of-flight system and our modulators are certified against hydrogen, and we can run nitrogen for both systems without issue.
Thank you, Anthony. Okay, let's squeeze in one more last question. So the question is, let me push that to the slide area. Is there a library that provides information to match data obtained from soft EI ionization? Perhaps
I can take
Laura,
that
would
one.
you be able to take? Oh, fantastic.
Perfect.
Please.
So for that, with the tandem ionization technology that we have, we can use software ionization energy, say 10 to 20 eV, and we have started building up our own library with the common ionization energies that we found very useful for things like terpenes and distinguishing structures of very similar compounds, so say 12 and 14 eV. But of course, it is not as expensive as what the NIST and Whaley libraries are that have been built up over many, many years. But what we do provide within the software is very easy ways for our customers to be able to bulk add all of the peaks from a standard mix, say, into a library. So we have made it as simple as possible to help customers build up their own libraries and make use of that tandem ionization data and do dual library matching. So you can then use your libraries that you've created to see both the 70 EV against commercial libraries and your soft EI against your tandem ionization library.
Thank you, Laura. Thank you for the insight. So that was our last question for today. So thank you once again, Laura, Jackie, and Anthony. I'm sure our audience has learned quite a lot from your sharing today. So thanks again for your time and insight. Goodbye.
Thank you, everyone.
Thank you. Bye.
Thank you.
So to those who posted questions that weren't answered because of time, don't worry. We will be responding to you via email instead. So before we end this digital classroom, we will appreciate if you could spend some time filling up the survey questionnaire on the right side of your console panel. This will help us to provide better webinar content for you in the future. Lastly, I would like to mention that you can also download the attendance certificate by clicking the certificate icon. If you have any further inquiries after this session or would like to contact us, please feel free to drop us an email at marketing@shimadzu.com.sg using the email widget found in the console. Or alternatively, You may also contact your local sales representative for more information. Lastly, thank you for joining us today. We hope you found this session both informative and inspiring. Wishing you all a wonderful day ahead, and we look forward to having you again. Thank you.
Excellence in science. Shimadzu.